Okay, let's check in this problem how to solve this one. It says 0.20 microfarad capacitor and a 0.10 microfarad capacitor are connected in parallel to a 6-volt battery. The potential difference across the capacitor is most nearly. Okay, so they are connected in parallel. They're connected in parallel, and it's asking for potential difference across the batteries most nearly. Oh, they are in parallel, so the answer should be 6 volt. Okay. Next, capacitor of capacitance C is connected in series with resistor R and battery of EMF E. The graph below shows a charge Q and the capacitor approaching a maximum value of Q max with increasing time T. So that's the expression which they are asking for Q max, and Q max will be definitely CE because that's the maximum charge which the capacitor can have. The slope of this graph represents, so slope has to be current, there's no doubt about it, because if you check the slope here, if we calculate, it is delta y over delta x, and we can see that in delta y or the y-axis you have charge and the x-axis you have time, and charge over time is current. Yeah, so we have got charge over time, which is current, and hence that should be the option. Instantaneous current, because in this situation, as the capacitor is getting charged, the current keeps changing. That's why we are calling it as instantaneous current. Okay, so instantaneous current, because we said it's instantaneous current, we can also write it as actually dy over dt instead of delta x. Dy over dx, because it's instantaneous, and the slope is actually changing from point to point. Okay, let's look at this one. Question number 17. Circuit P consists of 3 identical capacitors connected in parallel with a battery. Circuit S consists of 3 capacitors connected in series. So P has in parallel and S is having in series. When the capacitors are fully charged, what is the ratio of total energy stored in circuit P to total energy stored in circuit S? So energy is half CV square. So for circuit P, we can write half, and the C equivalent, so I'll write it as CP for the equivalent resistance in parallel, and V square, that's the battery's voltage, and ES will have the same formula, half, but this will become CS, and because it's connected across the same battery, it will be V square. So let's check quickly what is CP. For parallel capacitor, the formula is C1 plus C2 plus C3, because there are 3 identical, so it will be 3C, and CS will be C over 3. So EP over ES will be equal to, half will get cancelled, V square will get cancelled, so I can write it as CP over CS. CP is 3C and CS is C over 3. So we'll get this as 3 will go up, C will get cancelled, and we'll get this ratio as 9. Okay, next question number 18. A 3 microfarad uncharged capacitor is placed in a circuit with an ideal battery, 2 resistors, and an open switch S as shown in the figure below. The switch is then closed at t equal to 0. So at t equal to 0, the switch is closed. What is the current in the 10 ohm resistor at t equal to 0 seconds? Okay, so t equal to 0, that means the capacitor is beginning to charge and it's going to act like a short circuit for this capacitor, for the region of capacitor. So that means the current is going to flow through the capacitor and not through 20 ohms. Yeah, so your current I is V over R. So we can redraw the circuit. It would look like you have a battery, then you have a 10 ohm resistor and the capacitor. So that's 10 ohm and that's 30 volt. Because this is going to act like a short circuit. Yeah, so all the current is going to flow through this branch where there is capacitor, and hence we are not drawing 20 ohm. So this voltage will be 30 over 10 and that will come out to be 3 ampere. The next one, what is the current in 20 ohm resistor at t equal to infinity? Now at t equal to infinity, this capacitor is going to have full potential of, like, it is going to have full potential as the circuit provides, and hence there is no current which can flow through the capacitor. So now the capacitor is going to block all the current as if it is an open circuit. So now what we are going to do is we are going to draw the 30 volt battery and the two resistors, that is 10 ohm and 20 ohm. So we can see here we are not drawing the capacitor because the capacitor is now going to act as an open circuit because it has got the same potential as the rest of the circuit and it's not going to allow any current to flow through it. So now the current through 20 ohm is the same current which will flow through 10 ohm because now they are connected in series. So we will apply the Ohm's law. I is equal to 30 over, the total resistance is 30, so I is equal to 1 ampere. Excellent. Okay, next, a capacitor of capacitance C1 is charged and then connected to another initially uncharged capacitor. Okay, and the capacitor of the second one is twice the capacitor of the first one. Then we are closing the switch and the system comes to equilibrium. Which of the following is true of the charges in the capacitor and the potential difference across them? Okay, so potential difference across them, if they have reached equilibrium, that means potential difference across them would be equal, and hence we are left with two options, which is this one, not two options actually, three options we have got. Three options, this one, and this one. Yeah, they have V1 equal to V2 because it has reached equilibrium. That means there is no current flowing through it. There is no current flowing through it. That means there is no flow of charge, and hence the potential across the capacitance of the two capacitors must be equal. Okay. So we have to now choose which one of these three would be the correct option. So what we are going to do is we are going to write V1 is equal to V2. Voltage and capacitance are related by the formula V equal to Q over C. So I can write here Q1 over C1 and this is Q2 over C2. Q1 over C1 will keep as it is. C2 is twice of C1, which is given in the problem. So Q1 is equal to Q2 over 2. Okay, so that gives us option B. Okay. Let's look at the next one here. Capacitors C and resistors R1 and R2 are connected to a battery as illustrated below. Capacitor is initially uncharged. Battery supplies constant voltage V, and after the switch S is closed at time t equal to 0, which of the following graphs represent the current I1 through resistor R1 as a function of t? So we know that when we close the switch, capacitor is going to get charged. Yeah, so it is going to act like a short circuit in the beginning. Because it's acting like a short circuit, you're going to have maximum current flowing through R1. Okay. And as the capacitor's charge increases, as it reaches the potential of the rest of the circuit, what will happen to the current? The current is going to decrease. Yeah, the current I1 is going to decrease, and you can see that it decreases as shown in the diagram, D as well as in A. In both of them, it's decreasing. Okay, but we are going to choose answer as D. Let's see why. For that, we need to redraw the circuit and see how it would look like. So you have got a battery, you have got the resistor. So imagine when the capacitor is fully charged, you are going to have another branch for the current to flow. Unlike the case when R2 is not present. So if R2 was not there at all, then the current has to reach to 0. But here, because there is another resistor which is giving the current another path to flow, therefore the current is not reaching to 0. Okay, so that's the reason we have got the answer as D. Okay, I think we can keep the circuit and we can just rub out these. Okay, so here I can write when the capacitor is fully charged. Okay, that's how the circuit would look like. Okay, now this is quite simple because we know the formula. We are going to combine these two. These two are in parallel, so it will become 2C, and then 2C and this C, this C, they are in series, so 1 over 2C plus 1 over C, that will give you how much? 3 over 2C for 1 over C series. So let me just write it as CS, yeah, in the series. So CS will be 2C over 3, and then this one is left. You can see we have got this C and this 2C over 3, they would be in parallel. We can draw and see how it would look like. So you have got this C here, and the rest of the capacitance or capacitors we have combined, and we have got 2C over 3. They are now in parallel, so we'll get 2C plus 2C over 3, which will give you 5C over 3, and that's the answer. Okay, now let's consider the circuit below with an initially uncharged capacitor and two identical resistors. The switch is closed at t equal to 0. Which of the following is true about the currents IR and IC? The instant the instant the switch is closed. So when the switch is closed, so let's rewind and check the steps. When the switch is closed, at that instant, what's happening? It's going to happen, the capacitor is getting charged, correct? Capacitor is getting charged. That means it's going to act like it will provide a short circuit because its resistance is very or let's write provide a least resistance path. Yeah, so all the current is going to flow through C and there will be no current through R. So that's why we have got the answer as B. And the current through C will be surely, according to Ohm's law, the voltage, which is E, and the resistance in that circuit. In this circuit, we have got a resistance here, which is R. So that is there in the formula, E over R. Which of the following is true about the currents IR and IC at t equal to infinity? Look at this, t equal to infinity. So let's again look at the process which is happening. T equal to infinity means capacitor is fully charged. What do you mean by fully charged? It is going to act like an open circuit. Okay, it's going to act like an open circuit. Let me write down that properly. Open circuit means its resistance will be infinite. There will be no current. There will be no current in the capacitor. So IC will be 0. And all the current is going to go through the resistor. So if we remove like the branch of capacitor in the circuit and if we want to redraw, it would look like you have got a cell. So let me take another color. Okay, we have got a cell, we've got a resistor, and we have got another resistor. So this is R, and this is E. So the current IR will be E over 2R because we have got two resistors in series. Okay, capacitors C1 and C2 are connected as shown in the circuit below. C1 is C and C2 is C over 3. Equivalent capacitance between A and B is CEQ. A dielectric is inserted into the capacitor and the equivalent resistance has now become 2EQ. Okay, what is the value of dielectric constant of this dielectric? Okay, so now we need to recall what's the relation between the capacitance without dielectric and with dielectric. So if you remember, we did this last term in the previous chapter. So C equal to, I will write this as C dash, this is with dielectric, okay, is equal to K C, and this C is without dielectric. Okay, so let's check here. So we have got two situations, one before and one after. So let's make a small table here. This is before inserting dielectric, and this is after inserting dielectric. Okay, so before inserting, C total is equal to C1 plus C2, and there is a relation between C1 and C2. C2 is C over 3, so this is C and this is C over 3, and we have got this as 4C over 3. Now after inserting the dielectric, we are going to write as C total dash equal to. Now where are we inserting the dielectric? The dielectric is inserted in C2. So we are going to have this as C1 plus C2 dash. So C1 remains C, but C2 dash becomes K C over 3. And we'll keep it like this, okay? Now we need to find out what is the value of dielectric. So we need to use some other information from the problem. If you see, it says that after inserting the dielectric, the equivalent capacitance becomes 2CEQ. That means twice of what it was before without the dielectric. So we can write C total dash is becoming 2 times of C total. Yes. So we have got C total and C total dash in the previous steps. So we can write this as 4C over 3 equal to 2 times. I'm sorry, it's the other way around. So let me just remove this. Okay, so C over KC over 3, that's C total dash, is equal to 2 times of C total, that will be 8C over 3. Which we can solve. Okay, now I am like having less space here. I'm going to draw a line here. And let me see if I can write it down here. So I can have KC over 3 is equal to, I will take the C on the other side, it will subtract with the 8C over 3 and we'll get 5C over 3. So K will be equal to 5. Yes. So we have got the answer there. Okay. Let's go to the next one. Okay, identical resistors and identical uncharged capacitors are connected to identical ideal batteries of EMF E. Okay, so each circuit has a switch S in the open position. In which circuit will the capacitor reach half their maximum charge in the least amount of time when switch S is closed? So let's try to figure out what is it telling. Okay, so we are going to write here the formula for charge on a capacitor as it is charging. It is Q equal to Q max 1 minus E to the power of negative T over the time constant. Now it's asking that you have to reach half the maximum charge. So that means Q max over 2. This has to become Q max over 2. Q max 1 minus E minus negative. Okay. So we'll have half equal to 1 minus E. I'm just solving this equation to get some idea about what it's asking. So E negative T over tau equal to 1 minus half will be half. Okay. And I can take the natural log on both the sides. So negative T over tau is ln half. Okay. Now if I look at the value of ln over half, let me just check quickly. ln over half. Okay, so this is negative T over tau equal to negative 0.693. So T is equal to 0.693 tau. Okay, great. I think this we know from before. I just derived it again. Now, so time is depending upon time constant, and we know that we can write as 693 RC. So the time is going to depend on the value of R and C, and we have to keep it minimum because it's asking for least. So we know that resistance in parallel will become less. Okay, so this circuit C seems to have the least resistance. Okay, and we also know that same happens for capacitance in parallel. So this one is going to have 3 capacitors, and 3 capacitors means its capacitance is going to be quite less, because in capacitance in parallel, in series, the formula is in the reciprocal form. So the option is E, because it has got 3 capacitors. Okay, in part C we have got 2 resistors, and in part E we have got 3 capacitors, so it should be E. Yeah. Okay. In the circuit shown, the switch has been set on contact A for a long time. At t equal to 0, the switch flips from contact A to contact B. How long will it take for the capacitor to dump approximately 90% of its charge across the resistor? So when is it at contact A, it's going to get charge, and when it goes to contact B, it's going to discharge. And we need to know 90% of its charge needs to be discharged. So we'll write the formula QI minus T over RC. Yeah. So it has to dump 90% of its charge across the resistor. 90%, if it dumps, 10% is left with it. So 10 QI over 100. That should be the charge on the capacitor. QI E minus T over RC. I'll keep it as it is for the time being. So this becomes 0.1 e to the power of minus T over RC is 200 multiplied by 0.01. So 0.1 is equal to E minus T over 2, and then let's apply the natural log. So ln 0.1 is equal to negative T over 2, and let's solve this to get the value of T. So ln 0.1, I'm using my calculator to get the value, as you would also be doing. That comes out to be 4.6, and that's the answer. 4.6, yeah. Okay, so what we need to remember here, it says 90% of its charge is dumping across 200. So what is left on the capacitor comes in the equation. Next, switch S in the circuit shown below has been closed for a long time. Which of the following is correct expression for the current in the resistor? So which of the following is correct expression for the current in the resistor? So the keyword is long time. Long time means the capacitor is fully charged, so there is no current through the capacitor. So the current to the resistor will be found by Ohm's law, V over R, so E over R, and that's the answer. Next, suppose that the switch is opened at time t equal to 0. Now I think it's the same problem, same circuit. Yeah. Which of the following combinations of the differential equation and an initial condition can be used to solve for the charge Qt on the upper plate of the capacitor as a function of time t? So look at the word which is used, opened. So if you open the switch, the capacitor is going to discharge. So we are going to have only capacitor and the resistor in the circuit. And we have to write the Kirchhoff's rule for the capacitor and the circuit. So Kirchhoff's rule is written in terms of voltage. So we are going to write okay, so let's first redraw the circuit so that we are clear with the circuit. We have got a capacitor and we have got a resistor, because now it's discharging. So the capacitor is going to discharge and it's going to provide the current for the circuit. So the circuit will have the voltage of capacitor plus the voltage of resistance, or voltage across resistance, and these two should be equal to 0. And of the options which we have got, we are going to choose, so let me just quickly explain you before we choose. So voltage for a capacitor is written as Q for capacitor over the capacitance itself, plus we are going to have the voltage for resistor. So let me just mark the positives and negatives so that it becomes easier for us to understand, and the current is flowing this way. So we have got this as positive and this as negative for the resistor, just to get the direction of the current. So this will be and we are going to write the current as small I, because it's the instantaneous current. So we can write this as I times the resistance itself, so that's R, equal to 0. And we are going to write as negative because we cross the resistance and we reach negative. That's how we learned the Kirchhoff's rule, to apply it easily. Now a few things which we'll do here, because in all the equations they are using capital Q, so we'll stick to capital Q, and we are going to write this as Q over C plus negative dq over dt multiplied by R equal to 0. Okay, now we generally, because we will see that the charge on the capacitor is going to decrease, so this term dq over dt will itself be negative. Yeah, so in order to get the current as positive, we are going to write a negative with dq over dt itself, and we are going to write the equation as q over c plus dq over dt. I think I hope we have understood this. So we have got the equation q over c plus r dq over dt, and this should be 0, equal to 0. Okay, and not the negative one. We are not using the negative one. So once again, let's understand why we are removing the negative. Because the change dq over dt, if you look at the capacitor, as it discharges, it's going to lose its charge. Yeah, so as it loses its charge, the amount of voltage across it is also going to decrease. Yeah, so if the amount of voltage decreases, the current is going to decrease. That means this rate of change of charge which is happening in the circuit is actually decreasing. The charge is decreasing with time. That's why the change itself is negative. So that negative and the negative which was there in the equation, we combine them and we write it as positive. This is the equation for the capacitor when it is getting discharged. And the initial condition, what do you mean by initial condition? What was the charge on the capacitor when time was 0? We know that it had full charge, so that is CE. Okay, in question number 30, it's asking for charge on the capacitor and it's giving you what's the current. What is the charge on the capacitor when I is equal to 2 milliampere? So we know that the capacitor is getting charged. How do we know that? Because you have a capacitor add a battery, and the switch is closed. So let's see how to solve this one. Okay, so we have the formula Q max. Let me make it a little thinner. Yeah. So we'll use the formula for current because it's talking about current here, and then we will find the time from that, and then we will use the formula for charge. I think that should work. Okay, so let's see. Let's write down the formula for current. I equal to E over R exponential negative T over RC. So that's 2 into 10 to the power negative 3 equal to 20 over R. It's 4 into 10 to the power of 3 e to the power of negative T over RC. We will write that as 4 into 10 to the power of 3 multiplied by 50 into 10 to the power of negative 6. Okay, why this is not going? Okay, no problem. Okay, so yeah, now we have to get the value of T from here. So I'm going to calculate it and get the value of T from here. So we are going to have let me see if I can add, yeah, and I'm going to copy this from here, this whole thing. Let me just copy it. Can I? How do I copy it? Yeah, edit, copy. What was that we had here? We had here charge. We want to find the charge. So let value of C and E. C is 50 microfarad and E is 20. Okay, here 4 kilo that. Yes, we have got 600 microcoulomb. Okay, that's the problem which we are going to solve. Already written the equation for current. Is a charge in circuit, so we write the equation for the charging current and substitute the values. All this 2 into 10 to the power negative 3 equal to 20 over 4 into 10 to the power of 3, and this will be E minus T over, that will become 200, 15 to 4, and then 10 to the power of negative 3. So we can get the value of E. So before that, I want to just simplify a little bit. I'll take this on the other side, and I get it as negative T over 200 into 10 to the power of negative 3. So this becomes 8 over 20 equal to E negative T over 200 to 10 to the power of negative 3. Okay, and I can solve this. So ln 8 over 20 is equal to negative T over 200 multiplied 10 to the power of negative 3. So let me just quickly solve this. So ln 8 divided by 20. This comes out as negative 0.9163 equal to negative T over 200 into 10 to the power of negative 3. 0.9163 multiplied by 200 multiplied by 10 to the power of negative 3. So T comes out as 0.18326. Okay, so now that's the time. we have to get what was ahead and find the charge. Sorry. So Q is equal to Q max 1 minus e to the power negative t over RC. Now I have to go back and forth and get C is 50 microfarad and E is 20 because Q max will be CE. That's why I'm writing that. I want to find Q and 1 minus E minus T. 0.18326, that's the value of T. And RC, what was the value of ohms? So 4 into 10 to the power 3 and C is 50 into 10 to the power negative 6. Let's check whether we get the answer or not. So that will be 1000 into 10 to the power negative 6 and 1 minus e to the power of negative 0.18326 over 200 into 10 to the power of negative 3. Now let me calculate that. So we have got e to the power of, so first let me calculate the power, negative 0.18326 divided by 200 into 10 to the power of negative 3, and that's the value of the power. So I'll write down that Q, I'll write it here, or maybe I can write down, yeah. So let's just let me just write here. So Q is equal to 1000 into 10 to the power negative 6, 1 minus e to the power of, this comes out as negative 0.9163, and now we have to do the rest of the calculation. Negative 0.9163, 1 minus the answer into 1000 into 10 to the power of negative 6, and I get this as 6 into 10 to the power negative 4. Let's check if we have an answer. So this can be written as 600 microcoulomb. So we have got the answer. Okay, let's solve this problem. Problem 31. Which arrangement has the greatest capacitance? So we can quickly calculate the capacitance of each one. This will be, the series will be C over 2, and then there's a parallel in there, so that will give you 3C over 2. Here the parallel will be 2C, the series will be, again, it's the same circuit as the before one, only just a little different in the diagram. So the value remains 3C over 2. This will be C over 3. Here the parallel will give you 2C, so 1 over 2C plus 1 over C, and that will be 3 over 2C, correct? 2C, and then this is 2, yeah, and 2C over 3, yeah, because these two are in parallel, so that gives you 2C, and then that's C in series with C, so that will be 1 over 2C plus 1 over C. The common denominator is 2C, yeah, and then you take the reciprocal, you get 2C over 3. Here you are going to these, all three are in parallel. All three are in parallel. So this will be C, because in parallel the incapacitance, it gets added up. So this will be 3C. It's asking for greatest equivalent capacitance, and that will be 3C. Okay, the next one in the circuit below, what is the expression for the voltage V supplied by the battery in terms of current I through the circuit and charge Q on the capacitor? So expression for voltage V, now that's quite simple. We know the voltage provided by the battery is equal to the voltage across the capacitance plus the voltage across the resistance. And so we can write this as VO of battery is equal to VC plus VR, and VC is Q over C and VR is IR. So that's how we have got that. The next one, an uncharged 3 microfarad capacitor is placed in a circuit with an ideal battery, 2 resistors and an open switch. The switch is then closed. Immediately after the switch is closed, what's the current in 10 ohm? Now this same kind of question we did before. So when the switch is closed, the capacitor is going to act as short circuit. Yeah, so all the current is going to flow through the branch where capacitor is there. So we can redraw the circuit. This is 10 ohm. Then you have got the capacitor, and then you have got the battery. Capacitor is going to act like a very less resistance path. So the current is going to be 30 over 10, that is 3 ampere. When here it says long time, that means now capacitor is going to act as open circuit. So we can redraw the circuit, and this time we are going to have the 10 ohm and the 20 ohm. We are not drawing the capacitor branch because it's going to be open circuit, and this time this will be V over R again. The formula remains the same. V is 30 and R this time will also be 30. That's the total resistance. Then that gives you 1 ampere. I think we did this before also. Yeah. Okay, let's solve this one. Capacitor in a single loop RC circuit is charged to 85% of its final potential in 2.4 seconds. What is the time constant for this circuit? Okay, so here it is giving you potential becomes 85% of the maximum potential in 2.4 seconds. That's the information which is given to us. Okay, so we want to find out what is the time constant for this. So we can now, let's see how to solve this one. Okay, so we can write this V as Q over C, and we will write here this as Q max over C. So we have got Q is equal to 85% of Q max. Now we can apply the formula for Q. So let's just quickly apply the formula for Q. No, I don't want that to happen. Why is it taking? Yeah, this one. Yes. So okay, so we will now apply the formula for Q. So let's write down that. So Q is equal to Q max 1 minus e to the power of negative t over tau. So we have got 85 over 100 Q max equal to Q max 1 minus e to the power of negative 2.4 over tau. We want to find tau here, and this is easy calculation using calculator. So we can write Q max. I've cancelled from both the sides, and I've got an equation for tau which I can solve. So I'm going to just rearrange it. Negative 2.4 over tau is equal to 1 minus 0.85, and let's just calculate this and get the value for tau. So we you know what to do. Next we are going to write this as e to the power of negative 2.4 over tau equal to 0.15, and then take natural log on both the sides. So 2.4 over tau is equal to ln 0.15. So let's do that. So this answer comes out for tau as, you can use calculator and check, it comes out, for me it is coming as 1.27 seconds, and yeah, that's 1.3 seconds. So we have got the answer for that. Last one on this page. Two capacitors C1 and C2 are connected in series with a 12 volt direct current source. The capacitance C1 is 600. When a voltmeter is connected across C1, the voltmeter reads 3 volt. Okay, so we will first draw the circuit diagram to understand this better. So we have got two capacitors and one battery. Capacitors C1 and C2 and battery is 12 volt. And we know that because it's a series circuit, the same amount of charge is going to flow through C1 and C2. That's an important fact. So if I get the charge for C1, is the same charge for C2. So that's what we are going to do. So Q1 is equal to C1 V1. C1 is 600, V1 is 3, so we get 1800. Don't forget micro was there, so microcoulomb, 1800 microcoulomb. Q2 will also be 1800 microcoulomb. So we can find, and V2 will be 12 minus 3, 9 volt, because that's in series. So we want to find C2. C2 will be Q2 over V2. Q2 is 1800 microcoulomb over 9, which is 200 microfarad. So this is 9 volt, okay? So 200 microfarad. That's it. This is done. Okay, in this problem we have got three identical resistors, a 30 volt battery, and a capacitor of 1 into 10 to the negative 9 farad. S1 and S2 are closed. Look at S1 and S2, they are closed, and S3 is open in the beginning. So what is the reading on the voltmeter? And the voltmeter is connected across R1, the first resistor. So we have got, so the circuit would look like this. You have got a resistor here, and then a resistor here, and then a resistor here. We are not going to draw the capacitor because the switch is open there. So this is R, this is R, and this is R. These two together, they are in parallel. So the equivalent will be R over 2. The total battery voltage is 30 volt. So definitely the ratio of the voltage would be like according to the resistors. So you will get 20 volt for this resistance, and 10 volt will be given to this parallel set of resistors, because their resistance is R over 2, half the resistance of the one which is connected directly to the or near to the battery. The next one is, what is the charge on the capacitor when S1 has been closed for a very long time? Very long time means its potential has to be same as the potential of the battery. So Q is equal to CV. C is 1 into 10 to the negative 9 into V will be 30. So we have got 3 into 10 to the power of negative 8 coulomb. Then 3 identical capacitors, each of capacitance C, are wired as shown below. 3 identical. When both switches S1 and S2 are closed, the equivalent capacitance is, now that's quite easy. We have got these two in parallel, so that will be 2C. So 1 over C plus 1 over 2C, that will be 3 over 2C. You flip the answer, 2C over 3. So that will be equivalent resistance. Next, an RC circuit is built using a 1 mega ohm resistor, an initially uncharged 20 microfarad capacitor, and a battery terminal with a terminal voltage of 5 volt. Which equation would be used to determine the charge in coulombs as a function of time? So let's look at the word initially uncharged. So we have the formula Q equal to Q max 1 minus E minus T over RC, and Q max here will be CE. C is 20 microfarad and voltage is 5. 1 minus E to the power of negative T. R is 1 mega ohms and C is 20 microfarad. So yeah, so let's check. So this is going to be 100 into 10 to the power negative 6. So I'll just rewrite it somewhere. So we are going to get this as 100 into 10 to the power of negative 6 and 1 minus E to the power of negative T, and this will be only 20 here because positive 6 and negative 6 will cancel and we get the answer there. Figure below shows 10 volt battery connected in circuit with 2 resistors, a parallel plate capacitor, 3 ammeters. It has been connected for a long time. Okay, which of the following correctly ranks the current in the 3 ammeters? Long time. What's the meaning of long time? Capacitor is fully charged, so it is not going to allow any current in A2. This one, there will be no current here. So A2 is equal to 0 and the rest of the circuit is going to act as series. So A1 and A3 are going to be same and A2 is going to be 0. Because 50, we can write here 50 ohm and 100 ohm, they will act as if they are in series because it's connected for a long time. Which of the following is correct about the voltage VC across the capacitor? Okay, so for VC, if you look at the voltage across the capacitor, we have got current in A1 as well as we have got some current in A3. So when the capacitor is fully charged, there is going to be some current drop in the 50 ohm. Sorry, some voltage drop for 50 ohm. And that's why we are going to choose this option where VC is between 0 and 10. It's not exactly 10, it's between 0 and 10. The reason being because there's a current which is flowing through this 50 ohm. Because in this particular circuit, we have 2 branches. If you look at this branch here, there is a capacitor and this branch there is a resistor. So when the capacitor is fully charged, we know that there will be no current through this branch. That's why we said A2 is equal to 0. But there will be current which will be in this outer loop because there's a full circuit here. Yeah, there's no break in the circuit. So because there will be a current in this 50 ohm, therefore the voltage drop for C would not be exactly 10, or the voltage across C would not be exactly 10, because there will be some voltage drop across this resistor, and hence we have got B as the option. Okay, so in this problem, let's check what is written. A circuit shown below has a battery and a capacitor and a resistor A and a resistor B. the circuit has been connected for a long time. So look at the word for a long time, with the switch open. Then at time t equal to 0, the switch S is closed. Which of the following graphs best represents the potential difference? That means when time is t equal to 0, capacitance or capacitor was fully charged. Yeah, so that means it has the maximum voltage. It had the maximum voltage, and hence we have to start with the maximum voltage graphs, which are B and C. So if you look at B, we have the voltage which is starting with the maximum voltage, and probably C also has some voltage in the beginning. But because it is getting discharged, the capacitor is now getting discharged. So what will happen to the voltage? The voltage has to drop or decrease. And hence we have got the option as B. Now let's check what's the next one. Capacitor is initially charged and then it's placed in series with R at time t equal to 0. What is the charge on the plates of the capacitor at time t equal to RC? So we are going to use the formula Q equal to QI e to the power of negative t over RC for discharging circuit. It's asking for charge. We are going to write QI. Initial charge will be C V0 E minus T e to the power of negative t over RC. We'll keep it as it is, and it says that T is equal to RC, so we can replace T there in the formula. So negative RC over RC, so that will be CV0 e to the power of negative 1, and that's option B. Let's check this one. The capacitor in the circuit shown below are initially uncharged. If the switch is closed, what is the maximum charge on 12 microfarad? What is the maximum charge the 12 microfarad capacitor will hold? The switch is closed. Okay. So now it's asking for 12 microfarad, and they both are initially uncharged. Okay, so now because both are uncharged, you will have the current flowing through the circuit, and we know that the capacitance and voltage, they are inversely proportional. So definitely the 12 microfarad capacitance or capacitor is going to have less voltage drop across it. Okay, so the total battery voltage is 100, because the ratio between the capacitance is 1:2. So the voltage for the 12 microfarad capacitance would be, it will take 1 part out of 3 into 100. Do you understand how did I get it? Because you can see that if let's say this is C1 and this is C2. Okay, so C1 by C2, I'm going to get 6 over 12, that is 1 over 2. We said capacitance and voltage are inversely proportional, so that means V1 over V2 is going to be 2 over 1. So V2, which is the voltage across 12 microfarad, is going to get 1 out of the total 3 parts. So the fraction will be 1 over 3 of the total battery voltage. So we will keep it as it is, and we'll write it as 100 over 3 volt. Yeah, so now let me just make it a little smaller. Okay, so now we want to calculate what's the maximum charge. We want to calculate what's the maximum charge, and charge, what's the formula for charge? Q is equal to CV. So we can write Q equal to 12 microfarad multiplied by V is 100 over 3 volt. Now if we calculate that, we are going to get Q as 400 microcoulomb, 400 microcoulomb, which is 4 into 10 to the power -4. Okay, so here it's telling to find the current indicated by the ammeter after a long time. After a long time, we know that the capacitor is fully charged, so there will be no current in the branch where the capacitor is present. So we are left with only 12 ohms. So I is equal to V over R, that is 24 over 12, and that's going to be 2 ampere.